Dear student, welcome to the lecture series of material science and physics. Today we will discuss about one of the most important topic, which is basically known as ion creation source. So in this lecture we will discuss about what are the type of devices which are used to create the ions. Okay, so dear student, basically the ion source is a device which create atomic or molecular ions. Basically, dear student, ion creation source devices are most commonly used in different types of equipments, and some of the well-known equipments in which ion creation sources are used are mass spectrometer. So basically mass spectrometer separate the different types of the ion on the basis of the charge to mass ratio. The ion source device creation source device is also used in optical emission spectroscopy or optical emission spectrometer. The ion creation source device is also used in ion engines, and it is also an essential part of ion implantation process. So dear student, please keep in mind that there are different types of ion creation sources. So today the part 1 of the lecture series of ion creation sources will be based on one type of the ion creation source device, which is basically known as direct current glow discharge ion creation source. Okay, dear student, the ion creation source devices are basically divided into 4 types. One of the well-known type of ion creation source is known as glow discharge. So dear student, the simplest type of glow discharge is known as direct current glow discharge. So in direct current glow discharge, basically a direct current is applied across the electrode in a glow discharge tube where there is a neon gas present at or any inert gas present at low pressure. So when the high potential around few hundred kilovolt is applied, which is a DC potential, it will result in ionization of the inert gas due to high direct current potential. And in this way, in glow discharge or in direct current glow discharge, ions are created. So these created ions are then extracted and transported into different types of substrates, and they are used in different kind of techniques like implantation or mass spectroscopy, etc. So this is the simplest method which is used to create this is basically simplest instrument which is used to create the ions. Another type of ion creation source instrument is known as inductive coupled plasma ion creation source. So inductively coupled plasma ion creation source, basically inductors which operate at high potential create a high current are used. Okay, so the high current which are basically produced by inductors will interact with the inert gas which will be present in a tube, and the interaction of the inductive current basically result into collision of the ionized gas inert gases, and this will result in creation of ions. So inductively coupled plasma in a source, in a simple word, is an instrument which is basically used an inductor which is incorporated across the tube in which the inert gas is present, and with the high current introduced by the inductor will result in the ionization of the inert gas, and in this way the ions are basically produced by the inductively coupled plasma source, and then they are extracted and utilized in different types of instruments or devices. Another type of ion creation source is known as microwave induced plasma source. So in microwave induced plasma source, a frequency of microwave somewhere around 2.45 gigahertz is used. Okay, so this high frequency will interact with the electron of the inert gases, so they will have a higher frequency, and these electron basically with high frequency and energy of the inert gas will basically interact with the other neighbor atom, and they will result into creation of ions, because the high energy electron having a frequency around 2.4 gigahertz have a higher energy. When they interact with the neutral atom, they will basically ionize the neutral atom. They will knock out the electron of the neutral atoms, and in this way huge amount of ions are basically created by the microwave induced plasma source. Another type of ion creation source is known as electron cyclotron resonance. Basically, this electron cyclotron resonance is basically used to interact with the frequency of the ion, with the frequency of electron of the inert gases. So due to the cyclotron resonance frequency and the match of the frequency of the cyclotron resonance frequency with the electron present in the inert gas will result in excitation, and they will basically cause interaction with the neighbor inert gas atoms, and as a result they will basically ionize the neighbor atoms by knocking out the electrons. So these are basically the four type of sources which are most commonly used to create an ion in the setups where the ions are required. So these are the main four types of equipments: glow, discharge, inductively coupled, electron cyclotron, resonance, and microwave. So these are the four basic types of instruments which are used to create an ion, and these ions are then further extracted and used in ion implantation and other types of techniques like mass spectrometry, etc. So dear students, let's discuss the type of ion creation source in brief. The first type of ion creation source is known as glow discharge. Basically, dear student, glow discharge, the word glow discharge is basically means a plasma. So a glow discharge is a plasma which is formed by a passage of electric current through a gas. Usually, the electric current in a glow discharge is passed through an inert gas, and which will result into ionization of the gas, and in this way we generate an ion from a glow discharge method. So this basically image clearly indicate that these are the electrode, and electric potential is basically of high current, or is basically introduced inside the tube, which is basically result in ionization of the gas, which is displayed in the form of sparks. And in this way, with the direct current, basically the ions in a glow discharge or even with the alternate current, the ion are basically created in the glow discharge setup. Okay, so dear student, in simple word, a glow discharge is a plasma formed by a passage of an electric current through a gas. So the passage of electric current, which is created by the electrode, will result into a creation of the plasma. Okay, it is often created by applying a voltage between the two electrodes in a glass tube containing a low vapor pressure gas. Usually a glow discharge is applied across the glass tube. Okay, usually it is applied across the glass tube, where the high potential is applied across the electrode in the glow discharge tube, and due to a high potential it will result into an ionization of the inner gas inside it, and they will generate an ion. So like when the voltage of which is applied across the electrode in the glow discharge exceeds the value which is known as a striking voltage, then if the voltage of this electrode applied across the if the voltage applied across the electrode exceed the striking voltage, which is a voltage required to ionize the gas, then if the limit of this applied voltage exceed, this will result into ionization of this inert gas, because it is not possible for the gases to sustain their inertness, because the incident potential have a striking voltage higher than the deassociation or ionization potential of the inert gas. So in this way, in a glow discharge, the plasma which is based on ion is generated on the application of applied potential across the glow discharge tube, and in this way basically we generate a wide range of the ion inside the glow discharge tube by the glow discharge source. So dear student, in a simple word, a glow discharge is a plasma formed by a passage of electric current through a gas. So basically a glow discharge is plasma. Plasma is a combination of electron, proton, neutrals and ions, and many more particles. So a glow discharge is basically a plasma which is formed by a passage of electric current through a gas. So when this electric current is passed through a gas, this high potential of the electric current will result in ionization of the gas, and ionization gas will result into a formation of plasma, which is a combination of electron, proton, neutrons and ions. Okay, so this instrument here in the figure basically is illustrating a glow discharge setup. And so in this setup, basically the high potential, this one is one electrode, this one another electrode, is applied across these two electrodes. The inert gas is basically inside the tube which is connected with those electrodes. When high potential is applied, this inside the tube, they will result in an ionization of the inert gas. So in this way a plasma is created, and which is a combination combination of ions and neutrals and different types of particles like electrons and protons. And from here the ions are extracted by the different sources in different kind of instruments, and then they are utilized in ion implantation and mass spectroscopy etc. So dear student, in a conclusion, when a high voltage is applied between the two electrodes in a glass tube containing a low pressure gas, result in gas ionization and the plasma formation at striking potential. So in a glow discharge, dear student, a high voltage is applied between the two electrodes, and this high voltage will result in ionization of the gas and formation of the plasma at striking potential. Let's make it more simple. So in glow discharge, a high voltage is applied between the two electrodes in a glass tube. Okay, so when high potential is applied in a glass tube using two electrodes, cathode and anode, onto a gas which has a low vapor pressure, will result into ionization of this low vapor phase gas. And when the low vapor phase gas vapor pressure gas ionized, it result into a formation of plasma at a striking potential. Let's break down this statement. So basically, a glow discharge is a technique which is used to ionize the low vapor pressure gas. Okay, so please note that this low vapor gas, phase gas, pressure gas have a certain binding energy, and in order to break the binding energy of this low vapor pressure gas, we need a striking potential. Okay, so when the striking potential or potential higher than the striking potential of the low pressure gas is applied, okay, in the glass tube in glow discharge system, this will result into deassociation or breaking of the low vapor pressure gas, and in this way the low vapor pressure gas will be ionized. And then this ionized gas is basically a combination of plasma, which is a combination of proton, neutron, ions or neutral atoms and many more particles. So in this way ions are basically created in a glow discharge. Dear students, there are some important factors to note. Number one is the low pressure gas. Why a low vapor pressure gas is used in glow discharge? Please note that low pressure gas is very important in terms of longer mean free path. So the low pressure gas have a longer mean free path, so this gas molecule will never or will have less possibility to collide with the boundaries of the glass tube of the glow discharge. So this will make the easy collision of the incident electron, which are basically generated from the cathode in the glow discharge system, and they can easily interact with the low pressure gas, and in this way the collision will be higher with the incident electron, and there will be a possibility of higher rate of the plasma formation and higher rate of the ion formation. Okay, so this, in conclusion, a glow discharge is a method in which a high voltage is applied between the two electrodes in a glass tube, which composed of a low pressure gas, and this high voltage will result into ionization of the gas which is present inside the glass tube, and it's when the glass ionized, the inert gas will form a plasma. But keep in mind the voltage applied across the electrode in glow discharge tube must be higher than the striking potential, which is the potential required to break the ions or to break the low pressure gas. Dear student, please note that glow discharge is widely used in source of light such as neon light. So they are commonly used in neon lamp or neon light, and there are also other types of lights in which glow discharge system is used, are known as fluorescent lamps, which are basically commonly used in houses. There are also wide range of application of glow discharge setup in plasma screen TV. So in general, dear student, please note that glow discharge has wide application. It is widely used, especially in different types of neon lights, fluorescence lamp, and plasma screen TV. But apart from this, they are also widely used in surface treatment techniques like sputtering etc. Okay, so glow discharge has a broad applications. Apart from devices like different types of lamp, plasma screen TVs, glow discharge is used in potential technique which like sputtering, which is basically a core of the microelectronic industry, and it is also used in doping industry in ion implantation setup. So dear student, this is all about part 1 of the lecture series of ion source creation and type of the ion creation source technique like glow discharge. So in the next lecture I will discuss first type of technique. It will be a continuity of the glow discharge, and I will explain a simplest type of glow discharge technique known as direct current glow discharge. So dear student, thank you for watching this lecture.